All right, so let's look at chapter 23 and problem number 1. So we got to find the critical value for a t for a 90% confidence interval. Degrees of freedom is 17. Then a 98% confidence interval with 88 degrees of freedom. Then a p-value for t is greater than 2.909 with 4 degrees of freedom. And then a p-value for the absolute value of t is greater than 1.78 with 22 degrees of freedom. Okay. So, %90 confidence interval means that we're taking the mean and we're looking at the middle 90%. So what does that mean? Well, it means we're going 45% that way and 45% this way. Hence, this is the middle 90%. So that means that we have 10%. We have 5% here, and we have 5% here. So going from left to right, where does this begin? Well, it begins at the 5th percentile. Going from left to right, where does this end? Well, it ends at the 95th percentile, because that would be 5%. Okay, so we're going to do inverse t. And we're going to do either the 5th percentile or the 95th percentile. And we're going to do 17 degrees of freedom. Okay? So let's do that. So we go to the calculator, second distribution, inverse t. And we're going to do, I'm going to do the 95th percentile. And again, this has 17 degrees of freedom. So that winds up being 1.74. Okay? If you did 0.05 instead, you're just going to get a negative value. It's the same distance from the mean, right? So this is negative 1.73. This is positive 1.774. Okay? So that's how you do problem A. Problem B is the same concept. Okay? Now we're going to shade in the middle 98%. We got 98%. This is 98%. Boom, there. Okay? So that means we have 2% left. So I have 1% here, 1% here. So if I go from left to right, I'm at the 0.01 percentile. And if I go from left to right, where does this end? It ends at the 99th percentile. Okay? So we're going to do inverse t. And then we're going to do 0.99 with 88 degrees of freedom. Okay? So let's do second distribution, inverse t. 0.99, 88 degrees of freedom. And we get 2.37. If you did inverse t of 0.01, 88 degrees of freedom, you get negative 2.37. Okay? So then question C is the p-value for t is greater than 2.09. Okay, so if we had 4 degrees of freedom, what that would mean, again, a t distribution is not static, it's dynamic. So it would be flatter like that. Okay, higher degrees of freedom means that it gets higher and the tails come in. So let's say that this is t is 0, because that's right at the mean. So 2.09 would be over here, and it said greater than. So we're going to shade to the right. So you remember how to do that? You go from 2.09 to 99, and then we got to put the degrees of freedom. We use norm CDF when we're doing normal models. We're not using a normal model. We're using a T model. So we're not going to use norm CDF. We're going to use TCDF. And that's this one right down here, number 6. So you're going to say, okay, calculator, go from 2.09 to 99. And then we have 4 degrees of freedom. So that area right there is 0.0524. So that's 5.24% of that curve is shaded. Now this thing right here, don't get too hung up on this. When it has the absolute value of t is greater than 1.78, and what do we got? We got 22 degrees of freedom. Okay, so what that means is, I'm going to put that here, t equals 1.78. Okay. So what this means is when I take the absolute value of something, then it always means positive. So the absolute value of positive t is t, okay? And the absolute value of negative t, okay, is also t. So really what that means is if I was to do t over here, and I was to take the absolute value of it, I would get a positive 1.78. So all that means really is it's another way of saying it's a two-tailed test. Okay. You're not going to see too many problems written like that, but just don't get all worked up about it. So all we're going to do, guess what? These two areas are the same. So all we're going to do is we're going to say, okay, calculator, find the area from 1.78 to 99, and then we're going to go 22 degrees of freedom, and then we're going to double it. So we just take that 0.044 and we times it by 2, and we get 0.0889. Okay, so this area plus this area would be 0.0889. Okay, and that's what that answer would be. So all that means is a two-tailed test. Whenever it's just one, like it was in C, then it's a one-tailed test.